All right, welcome. Today, we are diving into one of the most powerful and maybe one of the most underrated tools in all of mathematics. It looks like just a simple line, but trust me, it holds the secrets to understanding how every single number relates to every other number out there. Yep, we're talking about the number line.
But before we get into it, I've got a question for you. When you think of a number, say the number 5 or 20, what do you actually see in your head? Is it just the symbol? A collection of objects? The way we visualize numbers is actually the key to really truly understanding them.
So here's our game plan. First, we're going to build the number line from scratch. Then, we'll stretch it out and see what happens when it goes to infinity. After that, we're going to zoom way in and explore the hidden world between the numbers. And finally, we'll wrap up by seeing why this simple line is such a game changer for understanding math.
Okay, first up, numbers on a line. Let's take this abstract idea of a number and turn it into something we can actually see and point to. So what is it, really? Well, at its heart, the number line is basically a visual map. It takes all these numbers floating around in our heads and gives each one a specific address, organizing them in a way that just makes perfect sense. Let's build one right now. We start at 0, the idea of having nothing at all. Then we take one single step to the right, and boom, that's where the number 1 lives. We take another identical step, and we land on 2. And we just keep doing that. Same step over and over for 3, 4, 5, and so on. And doing this reveals the 3 sort of unbreakable rules of the road. As you move to the right, numbers always get bigger. And as you move to the left, they always get smaller. But maybe the most important rule is that the space between each number, like from 2 to 3 or from 8 to 9, is always exactly the same. That consistency is its superpower. Okay, so we've got our little line from 0 to 9. But numbers don't just stop there, right? So let's see what happens when we really start to stretch this thing out.
You've definitely seen that little arrow at the end of a number line before. Well, it's not just for looks. It has this really deep meaning. It's telling us that there's no last number. No matter how big a number you think of, you can always just add one more. This line never, ever ends.
So here's a cool way to think about it. Imagine trying to take a picture of an elephant. If you're standing really close, you can only get a picture of its leg, or maybe its trunk. You can't fit the whole thing in. The real number line is infinitely big, so any line we draw is just a small piece, a snapshot of the part we happen to need. For example, check this out. These 2 lines on the screen look like they're the same size, right? But if you look closer, the one on the right actually covers 10 times more ground than the one on the left. We've just zoomed out to fit a bigger piece of that infinite line into our snapshot. And this is a really important point. Just because we only wrote down 10, 20, 30, and so on, it doesn't mean that numbers like 1, 2, and 3 just disappeared. Of course not. They're all still there, hiding in their proper spots. If you had to find 65, you'd know exactly where to look, right in the middle of 60 and 70. Okay, so we've zoomed out to see the big picture. But what happens if we do the exact opposite? What if we zoom in? Let's go explore the hidden world that's packed into the space between the numbers. Seriously, think about that for a second. You have your mark for the number 1, and you have your mark for the number 2. Is that space between them just empty? Is it just blank space? Or is there something more hiding in plain sight? The answer is a huge yes. That space is actually jam-packed with numbers. This is where all the fractions and decimals hang out. For instance, the exact point, dead center between 1 and 2, that's the number 1.5, or as we write it in decimals, 1.5. Let's really see this in action. We're going to zoom way, way in on just that first section of the line from 0 to 1. And now let's chop up that space into 10 perfectly equal little pieces. So what are these new marks we just made? Well, that very first one is 1/10 of the way to the number 1. We call that 0.1. And the next mark? Well, that's 2/10 of the way there. We call that 0.2.
And then 0.3, you can see the pattern here. We can fill that entire gap between 0 and 1 with all of these new decimal numbers. But here's where it gets really wild. We don't have to stop there. We could pick that tiny little space between 0.1 and 0.2 and zoom in on that, and divide it into 10 parts to find the hundredths. And then we could divide those to find the thousandths. This process of zooming in, it can also go on forever.
Okay, so what does all of this mean? Let's put these 2 incredible ideas together. zooming out and zooming in, and see why the number line is such an amazing tool for understanding, well, everything. This right here, this is the big reveal, and it is truly mind-blowing. The number line contains not one, but two different kinds of infinity. There's an infinite number of whole numbers stretching out forever to the right, and there's also an infinite number of decimals and fractions packed into the tiny space between any two numbers. It's infinite in both directions, outward and inward.
So in the end, what does this simple line really give us? It's a map for the entire universe of numbers. It gives us a solid visual way to understand what bigger and smaller actually mean. It helps us see the whole big picture of math, and it's a tool that's always there, waiting to help us make sense of it all.
So I'll just leave you with this final thought to chew on. If something as basic as a straight line can hold a concept as wild as two different kinds of infinity, just imagine what other incredible, mind-bending secrets are still out there just waiting to be explored in the world of math.